Welcome to B's Math Lab. On today's edition, we'll be looking at Introduction to Probability. This is the aspect of mathematics that deals with events that we are not certain of their outcome. Usually in mathematics, we deal with events that we can always tell their outcome, like when we add numbers like 2 plus 2 will equal 4, or when we multiply numbers like 5 times 5, we definitely get 25. But when talking about things, or we say events like throwing a dice, tossing a coin, or when your favorite team wants to play, it's hard sometimes to say what the outcome will be. But with probability, we have a good chance to predict the likelihood of that event, if it will not happen, or might happen, or will definitely happen. Which brings us to the probability graph. This ranges from 0 to 1, where 0 is for the events that will definitely not happen, and 1 is for events we are certain or sure will happen. And in between are events we can only predict how likely they will happen, which is where we're focusing more on in our calculation. When trying to calculate the likelihood of an event, we say the probability of an event. This is given as possible outcome divided by total outcome. For instance, the probability of getting a tail in a coin is 50-50, or 1/2, because it only has 2 sides. And if you remember the formula, the possible outcome for the tail in a coin is only 1, and the total outcome, or we can say the total sides of a coin, is 2, which gives us 1/2. And this would fall in the middle of the probability graph, means any of the two can actually happen. Let's take another event, like picking a fruit randomly from a box which contains 20 fruits, where we have 12 strawberries and 8 bananas. The probability of picking a banana will be 8/20, because the total fruit there is 20, and it contains only 8 bananas, which is the possible outcome. And if we divide that, we get 0.4. Also, for the strawberry, will be 12/20, because we have only 12 strawberries, and after dividing that likewise, we get 0.6. And as we can all see, it is more likely to pick a strawberry than a banana if you were picking at random, because the strawberry on the probability graph is much more closer to 1 than banana, which is 0.4, which is much more closer to 0. And this actually makes sense, because the strawberry is more than the bananas in the box. Let's take some examples on probability. When a fair die is rolled, what are the numbers of outcomes we can get? And what is the possibility that when the die is rolled, we get a deal? From the question, we are actually dealing with just a die, and as we all know, it has only 6 sides. So the number of outcome is the 1 on one side, 2 on one side, 3 on one side, 4 on one side, 5 and 6, which equals to a total outcome of 6 on just a die. And to the next question, the probability of rolling a 3 will be the amount of 3 on the die divided by the total number of sides on the die. And as we can see, we have just 1 3 on the die, which will be 1 over the total side of the die, which is 6. So we have 1 over 6. This simply means that the probability of us getting a 3 when we throw a die is 1 out of every 6 throws. Now, let's take another example. If a coin is tossed twice, what is the probability of getting at least 1 head? As we all know, a coin has only 2 sides, the head and the tail. And we were told that this coin was tossed, or you can say flipped, twice. The first thing we are going to do is to determine the total outcome when the coin was flipped twice. So let's picture this together. Let's say when we flipped the coin, we get a head on the first row and another head on the second row, which we will call HH for 2 heads. Or it could have been a head on the first row, then a tail on the second row. That is HT, a head and a tail. Also, it could have ended up having 2 tails on both rows, which we will call TT for 2 tails. And lastly, it could have ended up having a tail on the first row, then a head on the second row, which we will call TH, a tail and a head. From this, which will bring our total outcome to be 4. Now, the probability of getting at least 1 head after flipping the coin twice will be 3, because from our outcome of all 4, only 3 of them ended up with just at least 1 head. That is the HH, HT and TH, and that we will end up having 3 over 4. From this, we can see that if you divide 3 over 4, you will have 0.75, which means we have a very high chance that when we flip our coin twice, we will end up with at least 1 head. Now, in this question, we have a box containing 12 apples, 14 bananas, 10 mangoes, and 6 watermelons. Find the probability of getting A, an apple, B, a watermelon, C, either apple or a banana, D, neither watermelon nor banana. We will be taking this step by step. So, as usual, we need to know our total outcome, which will build the sum of the whole fruits, that is 12 plus 14 plus 10 plus 6, which will give us 42 fruits. Question A says we should find the probability of picking an apple at random. That would be the number of apples, which is the possible outcome, divided by the total, which would give us 12 divided by 42. If we are to break this down, we will get 2/7. And question B says we should find the probability of picking a watermelon, and we have just 6 watermelon, which will be 6/42. Breaking this down likewise will give us 1/7. Quickly, before we answer question C, there are some statements we need to take notes of here, which is either and neither. Now, when we say either, we need to add the events and divide by the total. But for neither, we remove the event from the total and divide the result by the total. Now, back to question C, where we're told to find the probability of picking a fruit as random, that will be either a mango or a banana. Now, remember that either simply means to add the events. So it will be mango plus banana divided by the total outcome. Now we have our mango to be 10 plus the banana, which is 14, divided by 42. Adding those together, we will have 24/42. Now if we break this down, we will have the probability of picking mango or banana to be 4/7. And now to question D, where we're told to find the probability of picking neither watermelon nor banana, which simply means when we dip our hand into the box, we don't want to pick a watermelon or we don't want to pick a banana. Just like we said earlier on, when we are dealing with neither, we take away the event from the total. So we are dealing with neither watermelon nor banana, which simply means the total fruit minus the addition of watermelon plus banana divided by the total. From that, we'll have the total fruit, which is 42, minus the watermelon plus banana, which is 6 plus 14, all divided by 42. Now, when we add the watermelon plus banana, we get 20. And subtracting it from the total, which is 42, we'll have 12/42. So automatically, the probability of us not picking a watermelon nor a banana will be 2/7 after breaking them down. Now we've come to the end of this session on Introduction to Probability. I hope you all enjoyed this session. Now we have some practice questions which I know you will enjoy working on. And if you have any more questions, please move down to the comment section and ask. And please do not forget to hit the subscribe button and also the notification to be notified when we